of the main concepts in algebra is that we can represent an unknown quantity with a variable. And so variables are things like x or y or z. You want to be careful when you're writing letters with math. You don't want your z to look like a 2. That's why I put a line in it. I wouldn't use the letter O for a variable because it might look like a 0. So, you have to be a little bit careful. Sometimes, 9s look like A's and things like that. So just be careful when you're writing them. A lot of times I'll have a specific way of writing certain letters when I'm doing algebra. You can also use Greek letters or capital letters. Now there is a difference between a capital A and a lowercase a, or uppercase A and a lowercase a. In math and science, we're particular about that. So a lot of times, especially in the science classes, an uppercase letter will mean one thing and a lowercase letter will mean something else. So I recommend that you don't switch. If it's a lowercase a, keep it a lowercase a. If it's an uppercase letter, keep it an uppercase letter. Okay, but variables represent an unknown, something you don't know the value of. Okay, and a constant is something like that you do know the value of, like 7 or 3, and any other. Right now we're working with whole numbers, and so any other whole number that you could think of would represent a constant. 0 would be a constant. 4, and so on and so forth. 123, that would be a constant. All right, so we come to this symbol right here, which is pi. Oh, and by the way, on constants, they don't change, they don't vary. So you have variables. Variables are dependent, on what the value is going to be for that particular letter, an unknown. You may know, they may tell you at some point what the value is of a certain letter, but it's not given. A constant doesn't change. It's 7. 7 is a 7, and it equals 7. It doesn't change to another number. Okay, so now down here at the end we have this symbol. It's referred to as pi. It's a Greek letter, spelled Pi. And what do you think? Do you think it's a variable or do you think it's a constant? Well, I'm going to tell you. It's a constant. It has a value. A lot of times we'll approximate the value to be 3.14, or sometimes you'll see an approximation of 22 over 7. That one's not as common, but it's a better approximation. It's 3.14159, and that's as far as I go. Some people know pi to 100 decimal places, but I don't. Anyway, it has a value. So when you see pi, it's not a variable, it's a constant. It has that same value that doesn't change. We happen to represent that value with a Greek letter, so it's kind of a little bit different, but it is a constant. Okay, so now let's talk about the operations. We're going to talk about the 4 basic operations that we know. Addition, represented with, an addition sign, a plus sign. The answer to an addition problem is called a sum. So we could say, the sum. So you can say, well, what's the sum of 3 plus 2? And everybody would say 5, hopefully. Subtraction, the word for subtraction, a lot of times they'll use the word difference. So the difference between 2 numbers. And we use a minus sign to represent subtraction. Multiplication, the answer to a multiplication product a multiplication problem is called the product. So when they talk about product, they mean multiplication. And division, the answer to a division problem is called quotient. And I'll go into a little bit more here. Multiplication, when we have something like 5 times 6, we could represent it that way. We could represent it 5 times 6 with the little dot. The only problem with the little dot is sometimes it looks like a decimal and you have to be careful. So you can represent it with parentheses, multiplication. It's understood to be 5 times 6 here. But we do see the dots sometimes as well. Back when you first learned multiplication, you probably used like a little teeny X to represent multiplication. We don't use that so much now because we don't want it to get mixed up with our variables, and so we avoid that notation. But you might see it in scientific notation. They still use that. Okay, quotient. Quotient. We have two ways generally that we write a division problem, like 6 divided by 3. We use that division symbol, or we'll write it 6 divided by 3 with the bar, with the division bar. You might say, well, that looks like a fraction, but that's what a fraction is. That's division, okay? And so you're right. It does look like a fraction, but it means 6 divided by 3. And just so that you know, in a division problem, the number you're dividing by is the divisor, and then the number that it's going into is called the dividend. And you don't have to remember those, but sometimes it's handy to be aware. The answer then, in that case, 6 divided by 3, the quotient is 2. So, all right, so just a little bit more here. Talking about equality and inequality. Statements of equality, something like, we had something earlier, 3 plus 2 equals 5. And that is a statement. Statements aren't necessarily true all the time. This one is. 3 plus 2 does equal 5, so that would be a true statement. But it is an equation. It's considered an equation because it has an equal sign. And so that symbol, the two little bars there, the equal sign, makes it an equation, and it makes it a statement, okay? So statements can be true or statements can be false, but if there's an equal sign in the statement, it's called an equation, okay? And we have inequality symbols as well. So inequality symbols, there's less than, that's that symbol. So we could say something like, I'll do true statements, so I try not to confuse you, but 3 is less than 8. We could say something like that. That's the less than symbol. Maybe you learned earlier, you know, the alligator eats the bigger number if you think of it looking like a mouth. I remember I had one student, she didn't get the alligator part, but she would draw, she's like, oh, it's a Pac-Man, and the Pac-Man eats the bigger number. Anyway, well, don't leave it like that. If you're doing that on your paper, that's fine, but in the end, your statement would look like that. It's still a statement. Could be true, could be false. This one's true. 3 is less than 8, and so that's the statement that we have. It's not an equation because there's no equal sign. So it's called an inequality is what it's called when it's a statement that doesn't have an equal sign. Okay, there's also what we call less than or equal to. That symbol says that the number on the left is less than or could be equal to the number on the right. And so we could say something like 5 is less than or equal to 10. But you could, and that's true, but you could also say, also a true statement, 10 is less than or equal to 10. Now in the first one, 5 is less than 10. It doesn't have to be both things. It doesn't have to be less than and equal. It's less than or equal. So 5 is less than or equal to 10, so that's true. I'll put true here. But the second statement's also true. 10 is less than or equal to 10. It happens to be equal to, but it's also true. It's not less than, but it is equal to. So you might think, well, that's confusing, but sometimes we do such things, and maybe you're mailing a package and they say, well, you know, we'll charge you $5 to mail this package if it weighs up to 2 pounds. And so what if your package weighs exactly 2 pounds? Are they going to charge you $5 or are they going to charge you more than that? And so we want to know, okay, does that include, the 5 pounds or, I forgot now my example. Okay, so, but you get the idea, hopefully. All right, we also have a greater than symbol, greater than, so you could say something like, 10 is greater than 3. And then we also have greater than or equal to, similar thing, you could say 16 is greater than or equal to 2, but you could also say 16 is greater than or equal to 16, and both of those, all three of those statements would be true. Okay, so when we talk about inequalities in algebra, these are the inequality symbols we use quite a bit, less than or equal to, greater than, and greater than or equal to. There's one more symbol that we use sometimes, and it's the does not equal. And so sometimes you'll see that symbol. It doesn't make a statement an equation. It's still an inequality, but you could say something like 7 does not equal 8. You know? And that's a true statement again, but it's just saying the two sides of the statement are not equal to each other. Their values are not equal to each other. Okay, this video I thought was going to be short, and now it's long. But